Now let's check what happens when we multiply several sine functions together. Maybe 2 or 3 or even more. So let's start by drawing a line from the left to the right border of the screen. We start with this variable. We're gonna make the screen size to 500 times 300. And let's set a black background. And then I'm gonna do a while loop using the x variable. The x will go from 0 to the width of the screen, like we've done before. And I will increase x equals x plus 1. And this time I'm gonna use two variables. I will have a variable called a, also like angle, and also begins at 0, but I will increase this at a different rate. A equals a plus 0,03 or 3. Why have two? I could have one. We have worked before using just one variable, but then you have to divide, because we know the x variable increases too fast for our sine function. That's why I'm using a second variable here. So I will draw a point at the position x and y. I'm gonna set a white color, stroke 255. So x is defined, y is not yet defined. So I have to say here what's y, float y equals, and I'm gonna use the map function we discovered on the last episode. Here we will have the sine of a. Now we have to enter here what are the minimum and maximum values for the sine. So it's -1 and 1. And what kind of height do we want? This is the y variable, so we can say that we can get points between 50 and 250. So the screen is 300 pixels tall, so this is 50 pixels from the top and 50 pixels from the bottom. And let's see, what do we get? Nothing, because stroke doesn't exist, but it's stroke. And here is our sine wave. This is the representation of our sine function. So we know that if we increase this here, this is the speed at which this angle increases, then we have a higher frequency. If we increase this slower, then the frequency is much slower. So the question was, what happens when we multiply this sine here by another sine? First, let's try using exactly the same angle and see what we get. Okay, do you see the difference? Now it's going from this 50 pixels from the bottom and 50 pixels from the top. But if we multiply this by another sine function, it's moving just around. It looks like it's the middle of the screen, and this is still 50 pixels from the bottom. Now let's multiply this a here by some value. For example, 1.2, and see what difference that makes. That's strange. Now we have the same wave, but is going up. What if we increase this 1.3? So I think you can start to see this is like a wave inside a wave. It looks like we are getting the effect of two sine waves, and one is going, it's like one is riding on top of the other. What happens when we type 2 here? That's a quite interesting one. It's quite weird, and you can see it's always repetitive. But the more coefficients you add here, if we would add another times sine a, I don't know, 1 times 1.7, I'm gonna multiply this, the more complex it gets. And let me explain something about this thing about multiplying these sine functions. We know that the sine function returns a number that is between -1 and 1. This is sine of something. When we multiply this by another sine function, we are picking two numbers here, maybe this one and multiplying them together. Anytime we multiply numbers that are in this range, that are between -1 and 1, we will get another number that is still between -1 and 1. We can type here some examples to see why is this happening, or some tests. For example, if I multiply -1 times 1, we get -1. So we're getting this number here. If we multiply 1 times 1, obviously that's 1. So it's here. If you multiply -1 times -1, we get 1. The signs, the negative signs are cancelled. And 1 times -1 is -1. And this is happening only for numbers that are in this range. And it happens that the sign function is returning numbers that are exactly in this range. Let's see what would happen if we take the numbers that are between -2 and 2. When you multiply 2 times 2, you already get 4. So you are getting a number which is outside of this range. Or when you multiply -2 times 2, then you would get -4. So this special case, it's happening only. We have talked already before that the number 1 is somehow special. It's like a boundary. So that's why we can keep multiplying all these sign functions together, and we can be sure that the result is still going to be between -1 and 1, which is perfect for our map function here. So we can say that still that even we are multiplying all these sign functions here, the minimum is still -1 and the maximum is still 1. So I'll let you try. You can try different amount of factors here. You can add more times sign of something, and you can try here with different numbers. You can try the difference between if they are integers or if they have some decimals, like let's try 1.1 and 1.2. What happens then? And you get quite interesting shapes. If you would increase here the rate, maybe you can see that it at some point is repeating. It may take a long time. When the more factors you add, the longer it will take to repeat. If you just have one factor, then you can see very obviously it's repeating on all these peaks. But when you add more factors, then it becomes more complex.